In binary FSK, the given signal waveforms are U0 of t is that waveform over that duration, and U1 of t is that waveform over the same duration, where capital T is the bit duration interval, and it is in and t is in seconds. Both U0 of t and U1 of t are 0 outside the interval. With a matched filter correlator based receiver, what is the smallest value of t in microseconds required to have U0 of t and U1 of t uncorrelated? So we've come across a similar question before, and we know we perform an integral and we end up with some two sinusoidal functions with frequency f1 minus f2, in this case 4000 minus 24, and you end up with this value, which is really pretty close to 4 kilohertz. And the other one is f1 plus f2, and 4000 plus 24, also both very close to 4 kilohertz, because 4000 is much greater than 24. So we perform that integral, and that leads us to this equation, which we can evaluate to sine 2 pi multiplied by 3976t over that, plus sine 2 pi blah 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 over 2 pi, and we know the drill. The sum is only possible, this sum which equals 0 is only possible if both of these values, 2 pi times 3976t and 2 pi times 4024t, both of them are equal to n pi. They are integer multiples of pi, so that the sum disappears. They're both equal to 0 because sine n pi is equals to 0. Then for minimum bit duration, in this case we'll just take 4024 pi t is equals to pi. We said we take the most basic case when n is 1 for minimum bit duration. So if we say 4024 pi t is equals to pi, and notice also we ignore the value of 2 pi, because 2 pi is still equal to n pi. It's an integer multiple of pi, so we can ignore it. So then we have t will be equals to 1 over 4024, which really, as I mentioned, 4024 is really very close to 4 kilohertz. And that brings our value t over t is equals to 1 over 4024 to 250 times 10 to the minus 6. It's very close to this. It's approximately that, 250 microseconds.